Hey, welcome everybody to 9.5, Addition, Subtraction, and Complex Fractions. So today, instead of just simplifying fractions, we're going to actually be adding and subtracting. So, to start off with, we're going to review how to add and subtract fractions. I'm hoping that most of you remember this, but for those of you who don't, when I'm adding or subtracting fractions, I have to have a common denominator. So if I look at number 1, I've got 1/2 plus 3/4. Before I can add fractions, I need the bottom number to be the same. What you want to do then is look for a number that is a common multiple of 2 and 4. And when I say multiple, I mean 2 times 1, 2 times 2, 2 times 3, so on. And you could use any multiple, but it's the fastest if you use the least common multiple. So in this situation, 4 would be the least common multiple. I want to make the bottom of this first fraction be a 4 then, so I want to multiply it by 2. I can't just multiply the bottom by 2, I have to also multiply the top, so I multiply the fraction by 2 over 2. So that's actually the same thing as 2/4. Once I have the same bottom, add the top, bottom stays the same. And now once you have the same bottom, it's as if I have 2/4 plus 3/4. How many fourths total do I have is what you want to ask yourself. Now remember, there's a lot of common denominators you can have. So let's look at number 2. And when I look at this, the least common multiple or least common denominator would be 12. Some of you, though, may have been thinking 4 times 6 to get 24. And now either one's okay, but if you use the lowest one, it will be less reducing later. So that's what I'm going to use. 4 and 6 both divide into 12. Check this out. To get 12 here, I need to multiply by 2. To get 12 here, I need to multiply by 3. So the first fraction ends up being 9/12, and the second fraction ends up being 10/12. So my final answer is -1/12. Alright, I want you to pause the video and try number 3. Alright, I got 47/56, and 56 ends up being the least common multiple as well. Alright, so I hope at this point you're kind of like, oh yeah, that's easy, I remember how to do that. It gets a little harder to find that common denominator when we have variables, so that's the next thing I want to talk about. Starting out easy, and when I say least common multiple, that would be the bottom number I'm looking for. A multiple are things that multiply. I multiply by my number to get them. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So these are all multiples of 3. Here's the multiples of 7, 7, 14, 21, and so on. I want to stop though. When I find the least common multiple, I want the smallest number that matches in both lists. And it ends up being 21 in this situation. Alright, so here's what you do when you have variables. In this situation, x and 5 have nothing overlapping. First you want to ask yourself, is there anything that's overlapping? In this situation, there's not, so 5 and x are both in there for the least common multiple. You know what, let me just do a few and then I'll come back and clarify. Let's look at D next. Alright, here 2 and 3 are just different numbers. The least common multiple of 2 and 3 would be 6. I knew that in my head, but if you needed to, you could write out the multiples. Now, when I look at x squared and x cubed, here's where it gets tricky. So the least common multiple is the smallest thing I could put so that both lists, everything's satisfied. Now this one has an x squared and this one has an x cubed. I can't put x squared because that would be smaller than x cubed, and x cubed is the biggest one, so that's what I put down. Here's kind of like the shortcut I usually tell my students. You want to use every factor you see. You don't have to repeat unless it happens twice, and if you have variables with exponents, you're looking for the larger exponent for the least common multiple. Let me say more. Let's look at C. So in this situation, you might be thinking, oh, they both have an x. Doesn't work that way if this is locked in there with a parenthesis. So in this situation, x counts as one factor and x plus 2 counts as the other factor. So my least common multiple would be me just multiplying the two numbers together. Looking at E and F, I can't really figure out what the factors of this are because it's a trinomial. So what I'm going to do is I'm going to factor it first, and then I'll find my least common multiple. All right, I want two things that multiply to be -6 but add to be -1. So think, what two things multiply to be -6 but add to be -1? All right, I'm thinking -3 and 2. All right, here's how this works for finding the least common multiple. Now both of them have a x minus 3, so that's going to be part of it. This one also has a x plus 2, so I'll put that down. So I don't have to put the x minus 3 down twice because it only appears once in each list, but I have to make sure everything's included that appears. So let me just go back and say more then. When I go back and look at B, I had to use everything that appears in my lists, 5x, didn't have to repeat. I use every factor that appears. I use every factor that appears, and x cubed is the bigger one, so that's the one I had to use. All right, let's look at F. And I want to be honest with you, this is going to become more clear as we go along. I realize that I'm not giving you very specific rules here. I'm just saying some stuff. There aren't really specific things I can tell you that work in every situation, because every situation is going to look a little bit different. That's why I'm not being extremely clear right now. So you'll get the hang of it as we do more examples. Now, in general, though, I'm looking to find what the factors are, and I don't know, again, what the factors are of this trinomial. So first I'm thinking that I'm going to factor out a 2. So I divide each piece by 2, and then I put my leftovers in a parentheses. I've got x squared plus 8x plus 16 in the parentheses. And now let's continue factoring this. So I'm looking for two things that multiply to be 16 but add to be 4. So I'm thinking x plus 4, x plus 4. All right, now here's what you got to think about. What unique things do I have? I've got a 2. It's in both lists though, so I only need to put it down once. I've got an x cubed. I've got an x plus 4 and an x plus 4. Because one of the lists has it twice, that's why I would put it down twice. All right, let's keep going, and I'll show you how we can apply this to some problems. Now, example 2 actually starts out easier than what we just did, so we'll go through these two quickly. When I look at example 2, they already have a common denominator, so if two things already have a common denominator, you can just add it like a normal fraction. Even though the x's there, doesn't matter, just normal fraction. So bottom stays the same, then I add the top. 4 plus 2 is 6. Now the only thing that's a little bit different here is that we do want to simplify it. Of course the x just stays there, but 6 divided by 3 is 2. Alright, let's look at B. So again, the bottom stays the same if you have the same bottom, and then work with the top. And in this situation, because I have a subtract sign, 2x minus 4. Now I can't add those together, so I just write them both down. Think back to what we did in section 9.4. Is there anything on top and bottom I can cancel? No, so that's my final answer. All right, starting with example 3 is where we're going to use the least common multiple thing we were just talking about. So the thing is, I can't add or subtract these fractions until I have a common denominator. So I need to find the least common multiple to find a common denominator. And here's what we're going to do. First, factor it. And I mean the denominator. So factor the denominator. When I look at my two fractions I'm given for part A, on the left, 6x squared can't be factored. So I'm just going to look at the right. Think to yourself, what's the common number I could divide out of there? What's the common variable I could divide out? When you're dividing, you want the smallest one. I write down my leftovers. 4x squared divided by 4x is x. Negative 12x divided by 4x is negative 6. All right. And now I need to determine what I need to put on both sides. And now I just want to make a quick side note to help you understand what we're about to do. Let's suppose I have this problem right here. If I looked at the, let's make this a 4 just so you don't get confused. Okay, if I look at these denominators, this one has a 3 and this one has a 5. So this one is missing a 3, so I'll add a 3 to the top and bottom. the left one is missing a 5, so I'm not adding, I mean I'm multiplying a 5 on top and bottom. So our method is we're going to multiply by what it is missing. So look at this here. This one on the left, it's missing a x minus 6, so I put a x minus 6 over x minus 6. And it's also missing a 4. Now there is a least common multiple of 4 and 6 we could do, like I said before. So if I multiply by 4 over 4, it would be 24 on bottom. And if I multiplied by 3 or 2 instead, I could make them 12. But let's just, for this sake, make it 4, because usually that's what's going to happen, is that you can just use the other number you see. Anyways, so this one was missing a x minus 6. It was missing a 4. Does it have an x? It does. It actually has x squared, so we're covered with the x's. All right. Now, let's look at the right fraction. What does this have here that this one is missing? Okay, the one on the left has x squared, and this one only has an x, so I need another x to make them match up. This one has a 6, and this one does not. It's a 6 multiplied by it, not something locked inside there, so I need to also multiply by 6. And now, you know you are done if both of these bottom parts have the same chunks. So notice, a 4, a x minus 6, a 6, a x squared. Check. This has a 4, a x, x minus 6, x, and 6. Okay, but x times x is x squared, so we're covered there. So I hope you see what I'm saying. The bottoms have to have the same, all the same things all multiplied together. Here's what happens next. The bottom now, let's actually do 4 times 6, so that's 24. So I have 24 x squared times x minus 6. Now we're going to multiply this top out. And notice, you want to do things the simplest way possible. In this situation, if I multiply 4 times 5 first, that will be the simplest way here. So think, in my mind, I'm thinking, okay, 4 times 5 is 20, so I'm thinking 20 times x minus 6. So I'm going to distribute the 20, and I have 20x minus 120. And then for the right fraction, it has the same bottom as this one, because we made it so it has the same bottom as that one, remember? So it's going to be 24x squared times x minus 6. And then on top, this one's a little simpler, it just has 6x squared on top. Alright, last but not least, now it's a problem like what we did in example 2. So the bottoms are the same, so the bottom just stays 24x squared x minus 6. But I add the tops, so I'm going to add them because there's a plus sign. I would just combine like terms if I could. None of these are like terms, so if there's no like terms, that means I just have to write it all out. 6x squared I apologize, suddenly Windows Journal is not letting me write. 6x squared plus 20x minus 120 is what you should have on top. But because Windows Journal is suddenly not letting me write, I'm going to just stop this video here and catch up with me again with part 2. Alright, welcome to 9.5 part 2. I now have Windows Journal working again as far as I can tell. So, for this first example A, we ended up with 6x squared plus 20x minus 120. And you need to know that the reason you want to try to use the least common multiple instead of just any multiple is because we're at a situation right now where all of these numbers that are separate, this counts as one group on bottom. So, but one thing out of each group separated by plus or minus signs is all divisible by 2. So I actually have to take this one step further and divide every chunk by 2. And now again, this whole thing counts as one chunk because it's all stuff multiplied together. That parentheses with the minus sign just counts as something multiplied together. And then these guys are separated by plus or minus signs. So when I divide by 2, I get a final answer of 3x squared plus 10x minus 60 divided by 12x squared x minus 6. Notice how everything in the parentheses stayed as it was. Alright, Let's look at example B. So again, I'm trying to figure out what my least common denominator is, and basically I got to figure out what does this fraction have that the right one does not, what does this fraction have that the left one does not. So please go ahead and factor the right fraction. I hope that you are thinking a 3x squared can be pulled out with a leftover of 2x plus 1. Alright, and now ask yourself the question, what does this one here need so that it includes everything that's included on the left? Notice the left includes a 3 and an x cubed. Okay, so this one already has a 3. Check. I don't need to put a 3 there. But this one only has x squared and this one has x cubed, so I need an x to make it match. Now ask myself, what does the right one have that the left one does not have? So we made it now so that the 3x cubed is going to be the same, check, but the one on the left does not have a 2x plus 1 on bottom. So this one I need to multiply by 2x plus 1 over 2x plus 1. Again, we're going to multiply the tops. So in this situation, I'm distributing that 4. I get 8x plus 4 on top of the left fraction, and now my denominator is going to be 3x cubed times 2x plus 1. For the right fraction, x times x is x squared, and I again have 3x cubed times 2x plus 1 on bottom. Once you have the same denominator, now is the step where I'm going to just rewrite the denominator, so 3x cubed times 2x plus 1, and then I add the top, combining like terms if possible, and I'm adding because it has a plus sign. So this time there's nothing that can match. So x squared plus 8x plus 4 on top. For our purposes, we're going to stop here. Sometimes some of the book problems, they might, after this step, factor and try to cancel. We're not making you do that for this class. So once you get to this step, you can be done. Once you have that finished written down, flip to the back. With C and D, we're looking at two problems that actually have the trinomial factoring where we got to have the two parentheses. So for me right now, why don't you pause the video and factor out both of the denominators for part C and go ahead and do D right away while we're at it. Alright, here's where we're at. X squared plus 4x plus 4 factored to x plus 2x plus 2, x squared minus 4 factored to x plus 2x minus 2, and then you can see these over here for D. Now, we're going to do the same process as before. Step 1 I factored. Step 2, now I'm looking at what is lacking. So check this out. The left denominator actually has 2 x plus 2's, whereas the right denominator only has 1. So to make the bottoms match, this one needs another x plus 2. And now when I look at the left side, see now the right side has 2x plus 2's and also an x minus 2. So this one on this side now needs an x minus 2. And we're getting a little more complicated now because they gave us a binomial or a two-piece thing on top here. And when I have a binomial times a binomial, I am going to have to actually FOIL it. So as they get harder, we're going to have to be doing more work. So here is me FOILing it. Firsts, outers, inners, minus 2x, lasts, minus 2. Alright, while we're at it, let's just combine like terms before I write my denominator to save some space here. So 1x minus 2x, 1 minus 2 is negative 1, or negative x. And then the denominator is x plus 2 times x plus 2 times x minus 2. And let me tell you something. If you have something that's just repeated, you can just write it x plus 2 squared because there's 2 of them. That saves you some time. So that's my first fraction. For my second fraction, I'm going to teach you something here that's very important and is new with example C and D. See how there's a subtract sign right here? That subtract sign goes with the 2. So when I'm going to distribute this, and there's two ways to do this problem. Let me just throw it out there. The first method is I could just keep it as a subtract and distribute the 2 and then distribute the subtract sign later. I personally like to distribute the subtract sign right away just because I think it saves time. Let me show you what I mean. I'm going to say this is a -2, and once I have used it and distributed it, now it's just plus. But -2 times x is -2x. -2 times 2 is -4. The bottom is the same as what we had on the left side, x plus 2 squared, x minus 2. And now because I've already distributed that negative, I put a plus sign there. And when I have a plus sign, that means I can just on top combine like terms. So when I look at this, I've got x squared with no partner. And when I combine like terms, I've got x squared, and then I have -x plus -2x. So remember, if it's -x, it's really like -1x. So -1 plus -2 is -3x's. And then for my numbers, I've got -2 plus -4. So -2 plus -4, -6. And then the bottom is just the same thing we've been working with, x plus 2 squared, x minus 2. All right, let's look at D. We already did one of the hard parts, which was factoring it, and now I specifically made this problem very similar to C so that you could have some extra practice doing what we just did. So again, think about what does this right fraction need that the left one has, but it's lacking right now. So notice the left one has 2x plus 3, so I need another x plus 3 here to make that match. And for the right one, I need another x minus 3, or not another one, but I just need x minus 3 so it matches here. All right. The left side, I need to FOIL that. So I'm thinking x squared, and then -3x plus 1x. -3x plus 1x is -2x. -3 times 1 for the lasts is -3. For the denominator, I've got x plus 3 squared times x minus 3. Now, for the right side, again, two options of doing this. You can distribute the subtract sign now or distribute the subtract sign later. Your choice. I am going to, again, distribute the subtract sign now. So that means once I use it, it's turned to a plus, but when I distribute it, these things are going to be negative now. So -1 times x is -x. -1 times 3 is -3. All right, my bottom is still x plus 3 squared, x minus 3. Combine like terms on the top. I got x squared. I got -2x plus -1x, so -3x's. And actually, that's the same thing I had before. -3 plus -3 is -6. There we go. Very similar to our answer for C. Let's look at E. All right, E is an example where you actually don't have to factor anything. I get to right away start multiplying. So again, ask yourself, what does the right side need? What does the left side have that the right side does not have? Notice the left side has x squared, the right side just has x right now. So to make it match, I need another x. That'll make it x squared. And then the left side has a 4, and this one does not, so I also need a 4. All right. What do I need on the left that the right side has? And when I look at this, it doesn't need an x because it already has all of them, but it needs a 5, so I'll multiply by 5 over 5. All right, I'm left with 30 over 20x squared plus 2 times 4 is 8, so 8x over 20x squared. Once I have my common denominator, that's just 20x squared. Add the top, 30 plus 8x. Those can't be simplified, but see how every single piece, every single chunk can be divided by 2. And this is something that students are often confused about, so we can talk more about that particular thing in class. But because all of them can be divided by 2, I can divide every number by 2, and then this fraction is going to be equivalent, it's just times 2. Think of it this way, if I took this fraction and multiplied by 2, would I have the same answer? Yes, so that means it's the same fraction, it's just scaled differently. Last but not least, today we're going to be simplifying complex fractions, and we are not going to finish all these problems in this video, so we will be finishing some of these in class. So this is in this section because we are actually doing kind of some add and subtract and multiply and divide in the same problem, and basically in order for me to figure out what this is, I want to pretend like this right here is a divide by bar, and if I'm going to divide two fractions, I need to actually make it so I have a fraction on top and a fraction on bottom. So the first thing I'm going to do here is add any fractions I have on top together, add any fractions I have on bottom together. And my goal is a single fraction on top, a single fraction on bottom. So notice the top already has a single fraction, so that is just as I want it. On bottom, we're going to now do the process that we just learned, where I need a common denominator. I'm looking, okay, what does this left side have that the right side does not? Has an x plus 2. What does the right side have that the left side does not? It has an x. And then I'm going to go through this problem. Now, I hope that at this point you might be at the stage where we know that both of the bottoms are x times x plus 2. Hopefully you agree with me. If it's all right with you, let's save some writing and let's just write that denominator down immediately. So we know it's going to be x plus 2, and I know I'm going to add together everything I have on top. So when I look at what I have here, x times 1 here is x plus, and I'm adding, and now 2 times these guys, so 2x plus 2 times 2, 4. Alright, so really my fraction looks like this. 2 over x plus 2, and then I've got 3x plus 4 over x plus 2. Don't multiply these out yet. I know it's tempting to change it to x squared plus 2x, but you don't want to because things are going to cancel. Alright, and here's what I was talking about with a fraction bar. What a fraction bar really means is divide. So what really is happening here is I've got 2x plus 2's divided by 3x plus 4 over x times x plus 2. So a fraction bar really means divide. So what I've done by writing it like that is I've turned it into a problem that's just like what we did in section 9.4. And I hope you now remember, oh, okay, 9.4, when I have a divide, change it to multiply, take the reciprocal, and the point of this is things should cancel. So in this situation, you can pretend like every chunk has a parentheses around it. The x plus 2 and x plus 2 cancel. So on bottom, I'm just left with 3x plus 4. And on top, 2 times x is 2x. So 2x over 3x plus 4. Thanks for listening. We'll do B and C in class.